Okay, so let's look at the example 2, which is the product of polynomial function or algebraic function and then a trigonometric function. So here we can say that our u of x is equals to x cubed and our v of x is equals to sine x. So obviously we are applying the Leibnitz theorem, and we are just going to state it. It is stated as the differential of a function n number of times of two functions, like what we are having here is, let's say, u of x times v of x. This is equals to the summation of the values from r equals to 0 up to the n number of times you want to differentiate, then n combination the r d of r of the first function, which is u of x, the x r times d of the second function, but this time n minus r over the x n minus r of v of x, like this. So this is the Leibniz theorem, and that is what we are going to apply in solving our question. So here we are just going to take the differential. So we have d 100 the x 100 of x cubed sine x. This one will be equals to, so we have summation r equals to 0 up to 100, because this thing here is 100. So we have r to be equals to 0 up to 100 of 100 combination r, the r of x cubed, the x power r times the 100 minus r, the x 100 minus r sine of x, like this. So since it's summation, we'll be taking the r values at moments. So we will say that when r is equals to 0, so when r is equals to 0, we'll have 100 combination 0, the 0, the x cubed, the 100 minus 0, the x 100 minus 0 sine x, like this. So 100 combination 0 is 1, and the differential of x cubed to 0 times is just like this. Okay, and then this one, we know that the differential of this one 100 number of times, this be times sine x plus 100 times pi over 2, and so this will imply that we will have s cubed sine x plus 50 pi. But if you do the expansion of this, let's say you have sine x sine cos 50 pi plus sine 50 pi cos x. This part will go to 0, and this part is 1, and so you'll be left with sine x. So the whole of this one, the whole of this thing will become s cubed. So this will imply that we have x cubed sine x, and let me call this equation 1. Okay, now let's go for when r is equals to 1, we will have 100 combination 1 d1 of x cubed dx power 1 times d 100 minus 1 dx 100 minus 1 sine of x, like this. So differentiating this one is just 100 combination 1 is 100, and differentiating this 1 times is just 3x squared times d 99 dx 99 sine x, like this. And so we have 300 x squared, and so this one becomes sine x plus 99 times pi over 2 sorry. And so this will imply we have 300 x squared sine x plus 49.5 pi. And when you do your expansion well, we are going to get negative 300 x squared cos x, and let me call this equation 2. So we take when r is equals to 2, when the value of r is equals to 2, so this will imply that we have 100 combination 2, then d2x cubed dx squared times d 100 minus 2 dx 100 minus 2 sine x. And so differentiating this one 2 times, you get 100 combination 2 is 4950, and times 6x, like this. And so times sine of x plus okay, so right now we have this one here, and so multiplying this by this, what do we get? We will get 29700 x, but this one will become sine x plus 48 pi. And so using your calculator to expand this and find the values, you get negative 29700 x sine x, like this. Let me clean this thing. Okay, so we can call this one maybe equation 3, and then we go for the last one. So we say when x is 3, when x is equals to 3, we will now have 100 combination 3 d3 of x cubed dx cubed times d 100 minus 3 dx 100 minus 3 sine of what? X. And so this one will imply 100 combination 3 is 161700, and differentiating this one 3 times is just 6. And so this one to that will sine 2 brackets x plus 97 times pi over 2. So this becomes 970,200 uh, sine x plus 40. Hey, sorry, here was 49. Sorry, this is 49. Not 48, please. So here is 48.55. Okay, so when you do the expansion of this and find the values, you will be getting something like 970200 cos x. And let's call this equation 4. And so now adding all equations 1, 2, 3, and 4. Adding all equations 1, 2, 3, and 4, we will now have x cubed sine x minus 300 x squared cos x minus 29700 x sine x plus 970200 cos x. And so grouping like terms, you will realize that we have this is cos x, this is cos x, this is sin x, and this is sin x, so we can put them together. So we will have 970200 minus 300 x squared cos x. Okay, because cos x is here, so we can have this, we can have this, so we have this and this over here now, plus we have x cubed minus 29700 x bracket plus sine x. And so we can therefore conclude the x 100 x cubed sine x is equals to 970200 minus 300 x squared cos x plus x cubed minus 29700 x sine x. And this is our final answer. Thank you for watching. Kindly subscribe.